Okay, so first let's classify each of the following as qualitative or quantitative. So remember, qualitative is your senses, like what is it? Smell, taste, sight, sound, color, texture. Quantitative is anything with a number. So that's pretty easy. Let's look through these options. This one has 4 hours, this one has 100 millimeters, and this one has 500. I don't even have to read the rest of it. I can see right away then that those are all quantitative. So quantity, like, oops, I spelled that wrong, my bad. Okay, quantitative. Okay, the other one then is the only one that is qualitative. All of the others are quantitative, like quanto. Okay, this one we're going to practice twice today. So let's make sure that we can use our measuring devices correctly. This could be on the test tomorrow. I could give you a ruler. I could give you a graduated cylinder. I could give you a scale, a thermometer. Those are all things we used to practice with. So the picture is not going to be just like this. It's going to be a different measuring tool. However, the questions are the same because when you're measuring with a measuring tool, everything that you need to know about it is consistent. So what is the value of each small line on the measuring device? And I specifically say that I want you to tell me in centimeters. So from here to here is 1 centimeter, but that's not the smallest line. These are the smallest line. So if 1 centimeter is cut 10 times, that means each one of these lines is a 10th, 20th, 30th, 40th, right? So these are each counting by 0.1 centimeters. You could have written a 10th, like that would be acceptable, but really it's 0.1 centimeter. Okay. So then what is the precision? The ruler is shown precise to what decimal place? So remember that whatever it's counting by, you're going to go one more than that because this line you can read in between the lines, and we'll do that here in a second. So in between the tenths, even smaller than that, would be the next decimal, which would be the hundredths. You could have also written the hundredths. I would accept that. According to the measuring device, what is the length of the line? All right, so I can cheat a little here. We can zoom in and let's see here. How far can I go? I mean, that's a little better. Let's see. Maybe it'll focus. All right, that's good enough. Okay, so this line here then, I actually think kind of ends in between this and this. So what is this? This is 4. I'm certain of the 4. I'm certain that it's past the 10th, but now it looks like it has stopped in between the 10th and the 20th. So you can say any number. You can guess. Do we want to say 5, 3, 4? I don't care. Okay? So it's a guess. So think about that in the next 2 questions. So let's write down our guess. So we're certain about our 4, our 1, and then we guessed in between the line here. So that is what this is asking. The measurement then has how many certain numbers? We were certain of the 4 and the 1. So that is 2 certain numbers. Any measurement, though, will always, the answer to this question is always a 1. You always guess in between the lines 1 time. So uncertain means a guess. Certain means how many of them were you certain about. Okay. So total then, that is 1, 2, 3 numbers, which is our significant figures. Okay. So we're going to practice that at the end of this one more time. But let's keep going. So now it says, convert the measurement to kilometers using dimensional analysis. This stands for please show your work. So to use dimensional analysis, the first thing you're going to do is write down your measurement. So the measurement was 4.15 centimeters. And now we're going to set up our proportion. It says I want to go from centimeters to kilometers. All right, but maybe you don't have that memorized. You don't know how many centimeters are in a kilometer. So you'd have to think about what did you put on your card? Maybe you put how many centimeters are in a meter. Like maybe you put that a centimeter is 1/100th, and maybe you put that kilo is 1,000. So it's most likely going to take 2 steps from centimeters to meters, and then another step of meters to kilometers or kilo. Okay. So remember that a centimeter, right, is this here. It's cut. If I had a meter stick, it would be cut 100 times. So I have to have 100 centimeters to make 1 meter stick. But a kilo means I have 1,000 of something. I would need 1,000 meter sticks to have 1 kilometer. So I would take meter sticks and I would line them up, 1,000 of them, and that would be a kilometer. Okay, so what does this mean now for math? Remember, there's an invisible 1 here. My centimeters cancel with centimeters, my meters cancel with meters. And I'll do it both ways, but technically this means 4.15 times 1 times 1, right? That's nothing. Divided by, remember that this is powers of 10. So 100 is 2 tens, 1,000 is 3 tens. So this is 1, 2, 3, 4, 5. So you really just need to put the 5 zeros there. And so when you divide, you can use a calculator. But really, you're just moving the decimal over 5 times. So 1, 2, 3, 4, 5. So the answer here would be 0.00000415 kilometers. Okay. Well, we also learned a different thing. We learned about scientific notation. That 5 that I just counted in powers of 10, we didn't have to do that. We could have instead just written this as 4.15 times 10 to the negative 5, right? Because I can move my decimal to here. There's always one number in front in scientific notation. So that's 1, 2, 3, 4, 5 spaces. It's a negative because this is a decimal, right? It's a tiny number. So a tiny number has the negative on it. All right. The next section is testing whether or not you know your rules about scientific or significant figures. So remember that there are the rules on page 3.3 in your workbook. So maybe you're going to write these down and give some examples. And then there's some examples here that we did about the rules for adding and subtracting, multiplying, dividing. Maybe put that on your card. So let's do this. I mean, you're going to have a calculator, so I don't care if you do this in your head or not. 4.5 plus 5.5 plus 5.75. Okay. The problem here is that our calculator doesn't know the rules of significant figures. So when you add and subtract, you keep the least decimal place. Okay. So in here, this went to the tenths, this went to the hundredth, this went to the hundredth, which means my answer can only go to the tenth, which means I have to round this. So this 5 is going to round the 7 up to an 8. So this becomes 15.8. And then don't forget your unit. This was a measurement of grams. Okay, let's do the same thing. We're finding the difference. So 4.54 minus 5.5. Oh, and then plus 5.756. Okay. Calculator gives me too many significant figures, but that's okay. We're going to fix it. This one has 100th. This one has 100th, and this one has the 1,000th. So that means I can only go to the 100th here. This 6 is rounding this 79 up to 80. But you want to keep all the way to the hundredths. So don't just put 4.8, just put a 0 there. And that makes it significant. So the 6 rounds this 79 up to an 80. And then don't forget about your unit of grams. Okay, that was the rule for adding and subtracting. Now down here, we're going to apply the rules for multiplying and dividing. And the rules for multiplying and dividing are to keep the least number of significant figures in your factors. And remember, a factor is just the two numbers that you start with, or in this case, we'll see that it's the same. Okay, this is also checking that you know what volume is, which you started learning in 3rd and 4th grade. So back here, if you forgot the equation for volume, and if you're not going to remember it on the test, it is here. So volume of a cube, right? Length times width times height. But if it's a cube and not a rectangular prism, that also indicates that they're all the same size, right? Like a square and then a cube. So that means each side, the length times width times height, these are all the same. So really, that's just 15 cubed. So what does that look like? 15 cubed would be 15 centimeters times 15 centimeters times 15 centimeters. All right, length times width times height, but they're all the same, so it's really just length cubed. And remember, it's a cube, and so that also tells you what your unit should be. So remember that part at the end. So let's do this. 15 times 15 times 15. Okay. My calculator doesn't know about significant figures, so I'm going to write the whole number down. There are 3, 3, and 3 significant figures in all of my factors, which means I can keep 3. So this is going to round to, that 5 rounds that up to 80. My unit here then was centimeter times centimeter times centimeter, so that's centimeter cubed. All right. Okay. The next one is, what is the speed of a car that traveled 20 meters in 60 seconds? So we can think about speed. This is just like when you're in a car and you look at your speedometer for the speed, you're going like 30 miles an hour, right? It's just the amount over time. So I'm going 20 meters in 6 seconds. So this is a division problem.
That's a fast car.
That's true. 20 meters in 6, maybe. Well, we can see. So 20 divided by 6, that would be, right, my calculator doesn't know about significant figures. So you're asking yourself, how many 3's can I keep? Well, this one had 3 significant figures. This one has 2 significant figures, so I can only keep 2. So this would round to 3.3 meters per second. Someone just said that was fast, so let's see if that's true. Let's practice converting this. So this is it. That's the answer. But let's practice converting this into miles per hour. So when we did this practice before, so we would need to change seconds into hours. So we would go seconds to minutes, minutes to hours. Okay? So that would get us into hours. So we know there are 60 seconds in a minute, 60 minutes in an hour. And then we need our, how many meters are in a mile? So when we did this practice back here, at the top of the dimensional analysis, we had that there we go, 1.61 kilometers in a mile. So we got to get to kilometers. And up top, we reviewed that it takes 1,000 meters to have 1 kilometer. And then we also need the fact that for every 1.61 kilometer, there's 1 mile. Okay, so meters and meters cancel, and kilometers cancel. And so now, what is this math? I've got 3.3 times 60 times 60 times 1 times 1, right? So on top, I've got 11880. And then on the bottom, for my time, I've just got 1 times 1 times 1 times 1,000 times 1.61. And so on the bottom, I have this number. This is division. You're going to divide the top by the bottom. Let's see if this is fast or not. Okay, so this would be 7.8 miles per hour.
That is so slow.
So nope, not as fast as we thought. So that's why it sounds fast when we do meters per second, but when you convert it, a meter is not as big. Maybe if this said 20 kilometers per second, then that would be crazy fast. That would be like, we're talking about a jet plane. But this is just 7.8 miles per hour. This is also a review then, just, we're going to do it on the back of the self-test, but remember you did do this entire page. So if you did it in practice, it could be on the test. Right? Just because I'm not putting it on the self-test doesn't mean it couldn't be on the test. Anything that you've done could be on the exam. Okay, this one we're kind of going to the easier stuff now. This is just recalling information. You also practiced on the GIM kit I had assigned. You can get extra credit for completing the GIM kit. 3 of you have already done that and turned it in. So perhaps if there's time today, you can do that. You're just identifying what's what. All right, so meters here. It's saying label each of the following with the correct abbreviation. Abbreviation means letter. So a meter is an M. A kilogram would be a kg. A cubic meter, be careful, this is a meter cubed. And seconds is an S. Okay, that's all that was asking for. On the next one then is the numbers. So this is why it specifically says label these with their values. Okay, a kilo, right? I have to have 1,000 meter sticks. You can think of this as meters, grams, liters, whatever you want. It's just a base unit. So kilo means I have 1,000 of my meters. Deci, these ones with the eyes, these are all tiny ones. So a deci is 1/10. So you could write 1/10, or you could write 0.1, whichever way you wanted to write it. A milli means that a meter stick is cut 1,000 times. So that's 0.001. And a centi is a meter stick cut 100 times. So that's 0.01.
Is the top one 0.012?
Nope, that's 1,000. It's a big number. Kilo means 1,000. Okay, 21 through 24 are practicing what we did a second ago, just shorter. So the key here is that you must show your work or you're not going to get credit on tomorrow's exam. So the first thing you're going to do is write down 9.5 grams and a multiply in a line. That's 1 point right there. Just writing that down. Okay. The next point is whether or not you put in the correct units. So I'm going from grams to kilograms. To get a kilo, we would need 1,000. So I need 1,000 grams to make 1 kilogram. My grams cancel. I now divide the top by the bottom. This is 9.5 times 1 divided by 1,000. You could use a calculator, but there's 3 zeros here. So you can just move the decimal over 3 zeros. So 0.0095 kilograms is the answer. So all I did was move the decimal from here 1, 2, 3 spaces because we're dividing by 3 tenths.
Do you want that in whatever the scientific?
You don't have to. You could also put it in scientific notation. It would be 9.5 times 10 to the negative 3 kilograms. I will accept both, but this doesn't specifically say convert, so you don't have to, but you could. Okay, next one, we're changing 11.2 millimeters into meters. So we're going millimeters to meters. Okay, remember on a meter stick, okay, to have 1 meter stick, it's cut into 1,000 tiny pieces of millimeters. Okay, so I only have 11.2 millimeters. That's really tiny. That is this is 10 millimeters. 11.2 is just right there. That's it. This is 10, 11.2 millimeters. It's tiny. So it's only that much out of 1,000 millimeters. So that cancels. I'm dividing again by 3 zeros, right? So this time I'm moving over 1, 2, 3. So that'd be 0.0112 meters. You could leave it in scientific notation, but you'd have to move it over 1 here. So that would be about times 10 to the negative 2 meters in scientific notation. Okay, the next one, again, you're just getting credit for writing down the steps. So if you forget anything, at least write down what do I have, and I need to convert it. What am I converting it into? I'm going from centimeters to kilometers. Well, this is kind of like on the last page. We weren't sure. So maybe we want to go centimeters to meters, and then meters to kilometers. Okay. So there are 100 of these centimeters. So if I had a full meter stick here, I only have 30. But a full meter stick would be 100 centimeters to have 1 meter stick. And then I would need 1,000 meter sticks to have 1 kilometer. Okay, centimeters cancel, meters cancel. I'm now dividing by 1, 2, 3, 4, 5 zeros. So again, you just move it over. So that'd be 1, 2, 3, 4, 5, 4, 5. Or you could put it in scientific notation, just leave it. 5.45. We already counted the negative 5 kilometers. Is that like this? That's almost the same as the other side. Okay, and the last one we had practiced. There was an example of how we change like minutes to days, hours to minutes. We did that previously. So let's figure out how we want to go from days to seconds. So we're going to write down our days. And then we would think, okay, well, what do we want to go to next? Days to hours? Okay, so days has canceled, right? In 1 day, there's 24 hours. Now I maybe want to go hours to minutes. Okay. In 1 hour, there's 60 minutes. And next, maybe I want to go minutes to seconds. Okay, and there are 60 seconds in a minute. So I can tell that I'm setting it up correctly because the things I don't want, day cancels, top and bottom, hours cancels, top and bottom, minutes cancels, top and bottom. And now I just have ones on the bottom, so you can ignore those. This would just be 30 times 24 times 60 times 60. That gives me 2592123 seconds. Okay, watch out for significant figures. In the beginning, there were 3 numbers here, so I can only keep 3 here. So that 2 is actually going to round away. That's going to round to 259, and then I replace it with a 0. 1, 2, 3, 4 zeros. We could practice changing that into scientific notation. Right, so I'd move it over to 2.59 times 10 to the 1, 2, 3, 4, 5, 6 seconds. Or the same number. Oh, all right. Now we're just doing what we practiced a second ago. Okay, let's change 35,000 into scientific notation. So I'm going to move the decimal from here to here. So that's 3.5, and then times 10, I would move it over 1, 2, 3, 4. So all this is saying is to put it back into 35,000, I would take 3.5 and multiply it by 10 4 times. This one's saying the opposite. I'm going to move it all the way until there's one non-zero number in the front. So that's the 9.5. And this time it's a tiny number, so negative 1, 2, 3, 4. Which just means to move this back here, I would take 9.5 and divide it by 10 4 times. All right, the last thing we learned was to be able to multiply and divide with scientific notation. And the rule was to just do the multiplication for the front 2 things, but then the exponents, you add them. So this would be 5 plus 5. And this one, let's use our calculator, 7.2 times 6 would be 43.2. Technically, you can't keep that 2 because there's only 2 significant figures here, so be careful. So this would give us 43 times 10 to the 5 plus 5 is 10. That's still not scientific notation, though. You have to only have one number in front of the decimal. So I'm going to move it over 1. So that becomes 4.3 times 10 to the 11th.
Can you drink of water?
And the last one, we're going to do the same thing. It's a division. So 1.25 divided by 4. Okay, so this is on top and this is on the bottom. And then these we're going to subtract. So this is going to be 4 minus negative 6. All right. And remember, yesterday we reviewed that subtracting a negative, you're getting rid of your negativity, is like adding a positive. Okay, you're getting rid of the negative. So let's do this math first. 1.25 divided by 4. Too many significant figures, right? This one has 3 and this one has 2. So I can only keep 2. So that would be 0.31 because 25 does not round that up. That just stays 0.31. Times 10 to the, we said 4 plus 6 is 10. However, I can't leave it like this, right? I have to have a 3 in the front. I can't have a 0 in the front. So that becomes 3.1 times 10 to the 9th. So how do I know to go down? Because moving it over 1 is like multiplying by 10. So I've already multiplied it by one of these 10s. So this is really 1 less 10, right? I go from 10 to 9 because I already moved it 1 to the right, which means I multiplied it by 10 already. All right, there is an extra self-test online that I have prepared for you to have one last chance to try this. And then I definitely have 3x5 cards of notes, right? Everything that we just went over, you should put some kind of definition or hint on there. Definitely, if you are having troubles memorizing any of these, that would be an easy thing to put on there. Maybe put an example if you think you struggle with setting this up, of going days to seconds or seconds to days, and then any of the definitions on here. All right, thanks for watching this video. Have a great day.